Imagine a car, right? A car that could run for 100 years without ever needing to refuel.
100 years.
Yeah, no gas stations, no plugging it in, just endless journeys. A whole century of motion on just one tank. Sounds like pure science fiction, doesn't it?
Certainly stretches the imagination.
Well, today we're doing a deep dive into exactly that. We're looking into the fascinating world of thorium and this really audacious theoretical concept. It pushes the boundaries of energy, of transportation.
And we're digging into our source material here, specifically something called the thorium car runs for 100 years without refueling.
Right.
So our mission for you in this deep dive is to really unpack how an idea this radical could even be conceived. We want to explore the incredible, almost unbelievable energy potential locked inside thorium.
And the thinking behind these designs, even if they are conceptual, designs that could just fundamentally change how we think about fuel and power.
Exactly. It's about understanding the what if.
Okay, let's get into it. A car that runs for a century. What is this stuff, this thorium, that could possibly make that even theoretically imaginable?
Well, what's really fascinating here is that the core of this idea, it revolves around thorium. Our source highlights it as, one of the densest materials we have on Earth.
Okay, dense.
It states a density of 11.7 grams per cubic meter. Now, just a quick note for clarity that unit, cubic meter, is probably a slip in the source. It's almost certainly meant to be 11.7 grams per cubic centimeter.
Ah, okay, that makes more sense. Still sounds very dense.
Oh, it is. Extremely dense. Think nearly twice as dense as iron. And it's that density that allows it to pack in just an incredible amount of energy.
So it's dense, but how much energy are we really talking about here? Give us some perspective, because, 100 years from one fuel source, it just sounds like forever.
It's hard to wrap your head around, honestly. The sheer scale of energy in thorium is genuinely astounding. The source notes it stores something like 20 million times the energy you'd find in the same mass of coal.
20 million times.
Yeah. And to put it in terms maybe more relatable, for you driving your own car, just 1 single gram of thorium, it contains as much energy as 28,000 liters of oil.
1 gram, like a paperclip's worth.
Roughly, yeah.
Yeah.
It's an almost incomprehensible concentration of power.
Okay, now this is where it gets incredibly compelling, thinking bigger picture. If we could actually tap into this energy, what problems, what global challenges could thorium potentially help solve for us?
Right. And this raises a really profound question. If this energy could be harnessed safely and efficiently, thorium could fundamentally change our whole energy landscape.
How so?
Well, for starters, it offers a potential solution, or at least a partial one, for meeting humanity's energy demands, which are just growing exponentially. That's a huge challenge.
And the environmental side.
Exactly. Crucially, it also offers a path towards dramatically cutting down greenhouse gas emissions, reducing that global warming impact from our current, dependence on fossil fuels.
But there's always a catch, isn't there?
There is, and it's a significant one. Thorium is radioactive. That's critical to understand.
Right. Radioactive. That sounds concerning for a car.
It means that for any system using thorium, especially something like a car, you'd need extraordinary safety measures. Think robust shielding, advanced thermal management, fail-safes upon fail-safes. It wouldn't be a simple swap for gasoline.
Okay, so it's a powerhouse, but it comes with serious safety considerations. Understood. So how does this highly radioactive element actually translate into powering a car for 100 years in this concept? Our source mentions laser power systems.
Yeah, laser power systems.
Yeah.
Inspired by this huge energy potential, they developed a theoretical concept. It wasn't a finished product, mind you, but a concept for a compact power generator.
Okay, what was their idea?
Their idea was essentially to build a laser, a special kind of laser, that actually incorporated thorium into its power source.
A thorium-powered laser.
That's the concept. And the key wasn't just generating steam, but how it generated the heat to make the steam. This thorium-powered laser would be aimed at water.
To do what? Just boil it?
Exactly. To heat the water incredibly quickly until it boils and produces high-pressure steam.
Okay, so you've got steam. Then what? How does that get the car moving?
Well, that steam is then channeled to turn a microturbine, like a tiny jet engine almost.
Right, turbine spin generators.
Precisely. The turbine spins, generating electrical energy. And that electrical energy is what would actually power the car's electric motors.
Ah, so it's kind of like a mini nuclear-powered electric generator inside the car?
In a very conceptual sense, yes.
Yeah.
By building the thorium right into this integrated laser steam turbine system, Laser power systems claim theoretically that this car could keep running for over 100 years
Without ever needing a refill.
without ever needing a refill. That was the headline claim.
Over a century. It's just wild to think about. What else did they claim about this concept car? Any specifics?
Well, even more remarkably, they claimed it would only need about 8 grams of thorium.
8 grams for 100 years.
Just 8 grams integrated into the power system. That was the calculation based on the energy density.
Wow.
And critically, the other big claim was that such a car would be entirely emission-free, at least at the tailpipe. No exhaust fumes.
Which obviously would be a huge deal for air pollution, climate change.
Absolutely. It would address many of the problems tied to fossil fuels. But again, it's crucial to stress the immense engineering hurdles. Containing and safely using that kind of concentrated radioactive power source in something as small and mobile as a car?
It's a massive challenge.
Huge, which is why this remains very much a theoretical, conceptual design, not something you'll see on the road anytime soon.
Right. So there you have it then. A deep dive into this, well, astonishing theoretical potential of thorium, and this concept car that could, in theory, run for over a century on just a tiny pinch of fuel, 8 grams.
It really is a glimpse into what truly radical energy solutions might look like down the road if we keep pushing the envelope in material science and engineering.
It definitely makes you think.
Absolutely. And if we connect this back to the bigger picture, concepts like this, even if they're just theories now, they force us to reconsider the fundamental properties of materials, how a deeper understanding could unlock entirely new ways of thinking about energy.
Like, what else is out there?
Exactly. When you consider the sheer amount of energy locked in a tiny bit of matter like thorium, it just makes you wonder, doesn't it? What other unconventional power sources might be hiding in plain sight, waiting for the right idea, the right innovation to turn theory into reality?
And maybe reshape our world in ways we can't even imagine yet. What assumptions are we holding on to about energy or transport that something like this just blows apart?
And what are the real barriers, not just technological, but maybe societal or economic, that stand between these kinds of revolutionary ideas and actually becoming commonplace? Lots to think about.